I have a test tomorrow, like the individual tests.
Okay.
So like I would say what we have to do are like 5 minutes of the like multiplication thing first though.
Let's do that. Let's start off there. That's always a good place to start. I prefer it if you bring the problems to the session. In other words, you can make up problems on systems of equations and complex numbers and all of that, but that's not as good as you doing it. That's not as good as you bringing the problem, because you bring the problems that you are specifically doing in class. I haven't been in your class, so I don't know for sure what you've been doing.
Yeah, while we're doing this, I can look for some problems.
You can find some specific problems and read them to me, and then we'll solve them. But
yeah,
let's do our 5 minutes on this. What's this?
this is 11. That is, it's positive,
Good.
but I don't know what equals.
56.
56.
That's one of the harder ones to memorize. So, and the only way I can even suggest you do it is to memorize it. Just remember that 8 times 7 is 56.
-5.
Good. I see you're getting quicker on those.
+8. -5. +120. +120.
When you multiply a number by 10, is all you do is you add a 0 to it.
110. -18. -3. 6. +6.
No.
Oh, wait. Oh, yeah, I know what went wrong. -12.
Yeah, whenever you see two negative signs like this, know that it's -3 plus -9.
Got it.
Okay.
The sign's going to be negative, but I don't know what would equal.
Okay, so the solution is to memorize it, but you can figure it out also. How do I figure it out?
By
What's 1 9?
Oh, this is that 9 thing.
Well, okay, that's something else. That's true. But I could also just go 9 plus 9 plus 9. Could I not?
Yeah, you could.
Okay, 9 plus 9 is 18, plus another 9 is 27.
Okay.
But you're right. 27 adds up to 9. 2 and 7, right?
Yeah.
So the easiest way to do it is to start your answer out with 2 and then figure out whatever digit you need to add up to 9. Well, it's 27.
They're going to be positive, and it's going to be 52.
32.
32.
Again,
Oh, no, why
I hate to have you do it in the following manner. What I really want to see is you memorize it. I want you to memorize your eighths table.
Got it.
Okay? But if you had to figure it out, it's 8 plus 8, that's 16, plus another 8, that's 24, plus another 8, that's 32. In other words, there are 4 8s that need to be added together.
Mm-hmm. Plus -11.
Good. See, this is easy. The harder way for this problem would be if it said -2 minus 9. But when they say -2 plus a -9, it's actually a relatively easy problem.
It's going to be a positive.
Good.
And I would say, 11.
Yeah.
11, yeah.
33 divided by 3 is 11. 44 divided by 4 is 11. Any two numbers divided by the same number is always 11. All right. I like what I saw. You're definitely getting better there, a lot better. And that's important. That's really important.
All right.
Now, I can certainly make up some systems of equations.
I found 2.
Okay, good. Hold on. I'll let you read them to me.
Could I type them in the chat, actually? I feel like that would be...
I'd rather you read them.
All right.
Because I got to write them one way or the other. Whether you type them in the chat or read them to me, I got to write them. And I would rather you get the experience verbalizing them.
Got it. So 6x minus 2y equals 10. And then the next line is 3x minus y equals 2.
What are your two methods of solving a system of equations?
Elimination and substitution.
Which one are we going to use here?
Substitution.
Elimination.
All right.
Here's what you look for to use elimination. That's standard format. What do I mean by standard format? I mean it's in the form of ax plus by equals c. If you see that format, in other words, your x and your y are on the left side and only a number is on the right side, then you're in standard format. And both of these are in standard format. When you see both equations in standard format, elimination is what you're always going to use. Take my word for it. Where you use substitution would be if one of the equations is not in standard format. In other words, if the second equation said this, well, that's not standard format. That's fully defined for y. Now, substitution makes more sense. So it depends entirely on how they give you the equations. So we're going to use elimination. How are we going to eliminate a variable?
By finding a number that both can be.
Tell me what the next step is. You don't need to describe it, just tell me what to do.
For both of the x's, we can times it by, we can times 6x by 2.
Hold on. This is equation number 1. This is equation number 2. Here's what you're allowed to do. You're allowed to multiply both sides of either equation by any number you want. You're also allowed to add equation 1 to equation 2 or subtract them. Either one. That's it. Those are the only things you can do.
All right. I would say times equation 1 by 2.
Think you mean equation 2 by 2.
Oh, yeah, actually.
Right. So I'm going to write a new equation 2. And I'm going to get it by multiplying the left side by 2 and the right side by 2, because I'm allowed to do that. And that gives me 6x minus 2y equals 4. And then I'm going to cross that out, because that's no longer my equation 2. I got a new equation 2. Now what?
Yes.
Now what?
Now we can eliminate 6x
How do I eliminate x?
by
Adding or subtracting the two equations?
subtracting the two.
Okay, so I'm going to subtract. Gives me 0 there. When I take minus 2y and I subtract the minus 2y, I get 0 there. But when I do 10 minus 4, I get 6. So I end up with 0 equals 6. What does that tell me?
That it is no solution.
Perfect. There's one of 3 answers. Either you have no solution, or you have an infinite number of solutions, or you have a specific solution where x is equal to a number and y is equal to a number. And whenever you get one number equaling a different number, you should recognize that that's impossible. There's no way that 0 can be equal to 6, and that tells you that there is no solution. What else you got?
Then we have x minus 3y equals 1. And then the second line is y equals 16 minus 2x.
What method are you going to use here? That's standard format, but this is not standard format.
So I would assume substitution.
Correct. So what's the next thing I'm going to write? So we're definitely using substitution. And the real key was the fact that I've got one equation where one variable is solved. I know what y is. I don't know what x is, but I know what y is. Y is 16 minus 2x. So whenever you have one of the equations completely solved, then substitution is generally what you want. If I had both equations completely solved, I would use substitution also. The only time I use elimination is when they're both in standard format. So I'm going to use substitution. What's the next thing I do? I still have equation number 1. I still have equation number 2. So what do I do next?
I don't remember how to do this, but I think we reorganize it.
What's substitution mean?
Oh, we substitute a number.
No, we substitute what y is. What is y?
Y is 1.
No, y is 16 minus 2x.
Oh.
So that's what we're gonna go into equation number 1, and we're gonna substitute for y. We know what y is. Y is 16 minus 2x. And now we have only one equation and only one unknown. You can always solve those. Whenever you get it down to one equation and one variable, that's solvable. Solve this for me. What's the next line?
The next line is honestly, I don't. Do we solve the stuff in the parentheses?
There's 2 rules. Always remember when you're trying to solve equations. Get rid of your denominators, get rid of your parentheses, and then proceed. Well, We don't have any denominators, but we got some parentheses, so let's get rid of it.
All right.
In other words, distribute this -3 to both the 16 and the -2x. That will get rid of the parentheses.
So we have to multiply the 16 and -2?
No, you got to multiply -3. The -3 is what is being multiplied.
Yeah.
So what's -3 times 16?
-3 times 16 equals -48.
Yeah, and I have no problem with you having a calculator in front of you and using a calculator for that. I don't need you to know how to do 3 times 16 in your head. Okay? You don't need to do that. You can use a calculator for that. What I do need you to know how to do is what's 3 times 2?
-3 times -2, you mean?
Yes, I do. Thank you very much.
It would equal +6.
Positive 6 what?
6x.
Okay. So, we've got rid of the parentheses. Now what's the next step?
48 plus. I'm sorry, I'm writing this down. The next step is to, I would say,
gather like terms. Remember that expression. That's always a step in an algebra equation, is you're gathering like terms. In other words, I'm going to gather all the x's together, and I'm going to gather all the numbers together. And I'm going to put all the x's on one side, and I'm going to put all the numbers on the other. So let's put the x's on the left side. How many x's do I have?
2.
I got 7 of them. I got 1 plus 6.
Oh, yeah.
So it's okay. I understand what you meant. But I really have 7 of them. Okay? How many numbers? If I put all the numbers on the right side, what should I write over there?
You should write over -48 and 1.
Okay, to move that 48 to the right side is all I do is move it over there and change its sign.
Yes.
So what's 1 plus 48?
1 plus 48 equals 49.
Okay, so that's what I want to write on the right side. In other words, I go from this line to this line, doing 2 steps in one. I combined all my x's on the left side. I combined all the numbers on the right side. What's the final step?
To divide both 7x and 49 by 7.
Which gives you that as an answer. Now, this started out as 2 equations, which means you always have to solve for x and y. Okay. Well, we solve for x. X is 7. If I go up and look at equation 2, tell me what y is.
Y is 16 minus 2x.
What is x?
X is 2.
X
Oh, what is
7. We just solved for x.
Yeah,
X is 7.
I thought you were talking about
2 times 7. Well, that's 14. 16 minus 14 equals 2. So there's our solution. We got x equals 7 and y equal 2. And you always have to solve for both variables. But you solve for them one at a time. In other words, we eliminate the y, or we substitute. In this case, we substituted, so that we had only one equation and one variable, just x. That allows us to solve for x. And then once you solve for x, you go back into this equation. Actually, it could go into either one, but this number 2 is the easiest one. and you substitute back for x, 7. And then you solve for y. So when x is equal to 7, y is equal to 2. And there's your solution. X equals 7, y equals 2.
Got it.
All right.
I can't find any problems, but it's that
I can make
x
some up.
equals, yeah, it's like x equals negative b plus or minus the square root, like b minus 4ac all over 2a.
That is the quadratic formula. So let's talk about that. Can you factor that?
Yes, you can.
Go ahead.
So you split the two x's in the parentheses. Look for both signs, and both signs are going to be addition.
Good.
And factors of 10, the best ones for it is 5 and 2.
Worded almost perfectly. The last thing should have been factors of 10 that add to the number 7.
I keep forgetting.
Okay, you did really good. Most people don't remember it exactly, but that's what I want to hear when I say verbalize it. It's factors of 10 that add because there's a plus sign in front of the 10. If that was a minus sign, then they would have to subtract. So they need to add to 7. Well, that's 5 and 2. Okay? So we can solve it as long as we can factor it. I can solve it easily. Okay? What if I give you this problem? Almost exactly the same. Now, you'll notice that if you go to factor it, you're not going to be able to. In other words, you could try x plus 3, x plus 3. That doesn't give you the correct middle term. And you could try all you want, you're not going to be able to factor. So, when you find a quadratic that you cannot factor, you use the quadratic formula, which is what you were quoting. Now, for the problem that I just wrote, tell me what A, B, and C are.
A is x squared in this.
It's always the coefficient only. There's never an x in these. These are numbers only. A is a number only. It's 1.
Oh.
What's B?
B is 7.
What's C?
C is 9.
Okay. Now we're ready to apply the quadratic formula. So what is x equal to?
X equals to 1.
No, substitute.
Oh.
In other words, what you're doing is you're taking this, and wherever you see an A, B, or a C, you're going to substitute what we figured out A, B, and C were.
So x equals negative 7 plus or minus 7 squared minus 4 parentheses 1 parentheses 9 over 2 parentheses 1.
Okay. Now let's simplify that. Minus 7 plus or minus, what's everything in this radical end up being?
Everything in that radical ends up being, sorry, 1 second, trying to find my graphing calculator.
You don't need it.
Oh.
What's 4 times 9?
4 times 9 is...
Apply the rules of 9.
4 times 9 is...
30 what?
33.
The second digit has to add to 9.
Oh.
So if the first digit has to be 3, what's the second digit have to be?
The second digit has to be...
a 6.
Oh.
They
How is it
add to 9. When you
Oh.
multiply a number by 9, your answer will always be digits that add up to 9. If I multiply 9 times 14, watch what happens. 9 times 4 is 36. 12, add 1, 2, and 6 adds up to 9.
Yeah.
That's the rules of 9. So if you're multiplying 4 times 9, you know the first digit is 1 less than 4, and now all you got to do is figure out the second digit has to be a 6. If it was a 5, it wouldn't add to 9. If it was a 7, it wouldn't add to 9. Got to be a 6. Okay? So what's 7 times 7?
7 times 7 is... Is there like a rule of 7s? I don't know. Wait, I did this like 2 minutes ago because my stepmom was asking a question about it. It's like 48?
49.
I was close.
And that's just another one you're going to have to memorize. However, I want you to know your perfect square numbers more than anything else. So let's go through those, because if you know your perfect square numbers, that's going to get you a long way. What's 1 squared?
1 squared is 1.
What's 2 squared?
4.
What's 3 squared?
9.
What's 4 squared?
12.
Nope.
8, 16.
What's 5 squared?
25.
What's 6 squared?
That's where you got me lost.
Well, okay. A good place to start then. 36. 6 times 6 is 36. 7 squared is, again, we just did it.
49.
8 squared. 64. 9 squared, you can use your rule of 9s. So what's 9 squared? The first digit got to be?
8.
What's the second digit got to be?
1.
That's it. And 10 squared?
10 squared is 1,000.
100. It's however many zeros. 10 squared means 2 zeros. 10 cubed means 3 zeros. So 10 cubed is 1,000. Okay? Now, I wrote those up there. Those are just part of your multiplication tables, right?
Right.
But they're the most important part. You need to know, you will get to a point in math where you need to know your perfect square numbers. You just do. You have to memorize what are your perfect square numbers. It's more important to know what 7 squared is than what 7 times 6 is. You need to know both, but you really need to know your perfect square numbers. So the ones you need to know are 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Those are numbers you want to recognize When I show you 64, you should be able to tell me that's 8 squared. Or when I show you 36, you should know that's 6 squared.
Yeah.
All right. Trying to get back to that problem. Let's see if I can. It's a very strange writing program that I have here, as you can see. All right. When it was x squared plus 7x plus 10, I was able to factor it and solve it instantly. The moment it didn't look so pretty, in other words, once it became x squared plus 7x plus 9, I can't factor it. The only way I can solve it is the quadratic formula. We got to this step right there. And now it's 49 minus 36. So it's 13 inside the radical. 2 times 1 is 2. There's our answer to this problem. In other words, if x is equal to either of these numbers, and it's important to know what that plus or minus means. What it means is one answer is minus 7 plus root 13 all over 2, and the other answer is minus 7 minus root 13 all over 2. So that means both. You plug it in there, you use both of them, or each one of them, I should say, to figure out both answers. And in all honesty, most quadratics are going to be of this format. They're not going to be nice and pretty and factorable, although they will be for you for a while. It's going to be more of a rarity that you have to use this quadratic format. But you basically have to use it wherever you can't factor. That's the bottom line.
Yeah.
What other stuff are you working on?
I think I just need help on actually like finding the vertex and all that on a graph.
Okay.
Like all the stuff for that. So let me real quick find something.
I can make up something.
Can you?
Let's start with that same original equation. That is a quadratic.
Mm-hmm.
So, if I say that's a function, well, what do I know about that function? It's a parabola, right?
Yes.
Okay. So, it's going to look something, I'm just guessing, it's going to look like that, okay? The reason I know that it points up is because it's got a positive coefficient in front of the x squared. If that was a negative number, it would point down. You with me?
Yes.
The most important point on that parabola is its vertex. That point right there. I want to know the x and the y coordinate of that point. That's always the first thing I want to know. Okay?
Got it.
A couple of ways to do it, but one that I think is the easiest in a lot of problems is if I want the x coordinate of the vertex, right, write that like that, it's minus b over 2a. Notice that that's the first part of the quadratic formula, right?
Right.
So what is that in this case? What's minus b over 2a?
Minus b over 2a is negative 7 over 2 parentheses 1.
So
2.
negative 7 halves. That is the x-coordinate, -7/2. Now, what's the y-coordinate of the vertex? Once I've figured out the x-coordinate, I can get the y-coordinate by plugging the x-coordinate into the function. So the y-coordinate is going to be -7/2 squared, right?
Yes.
Plus 7 times -7/2 plus 10. So I didn't mean to make the algebra this hard, but that's 49/4 minus 49/2 plus 10. Well, 49/2 is 98/4. And now I got 49/4 minus 98/4. That's minus 49/4 plus 40/4, which is the number 10. So my answer is minus 9/4. That is the y-coordinate of my vertex. So if you have any quadratic that's in standard format, and that is, you can get the x and the y coordinate using this method. And to me, this is the easiest method. There's 2 or 3 ways to do it. And I can go through all of them if you want. But it kind of depends on how they give you the equation. Now, let's say they didn't give us the equation as x squared plus 7x plus 10, but they gave us the equation as x plus 5 times x plus 2. Notice that's the same thing. Had we factored that, we would have gotten x plus 5 times x plus 2. Well, this tells me what my x-intercepts are. This tells me my zeros come at -5 and -2. Well, that's pretty helpful also, because now I know where I cross the x-axis. I cross right there at -2, and I cross right there at -5. So I know that my parabola looks something like this. And furthermore, I know what the x-coordinate is. It's halfway in between those two numbers. Well, guess what that is? -7/2. So the x-coordinate is -7/2, exactly what I got when I did it the other way. Now, if I want to know what the y-coordinate is, I substitute -7/2 into that, and what I will end up with is -9/4, just like before. So I did it a completely different way because they gave me the function in a different way. They didn't give it to me as x squared plus 7x plus 10. They gave it to me in factored format. And that's a different format for a parabola. That's called the X-Intercept Format. And when they give it to you in the X-Intercept Format, it's actually a little superior because immediately you know your X-intercepts, and figuring out the X-coordinate of the vertex is really easy. It's just halfway between those two numbers. So you add those two numbers, divide by 2, you get -7/2. And then to find the y-coordinate, just substitute -7/2 in for the x, -7/2 in for that. Do the multiplication, you'll get -9/4. So that's 2 different formats for a quadratic and 2 different ways to solve for the vertex. There's a third way, which might be the most common way that there is. And that is when it's in vertex format. In other words, vertex format is this: y equals a times x minus h squared plus k. For example, 2 times x minus 3 squared plus 4. That's called vertex format because you're looking at the vertex. H and k are the vertex. So what's the vertex of the one I've given you right here?
The
Where's the vertex located?
The vertex is the parentheses, I think.
Well, what number? Give me a coordinate. I've given you everything you need to know the vertex right there.
3.
Good? 3 and what?
3, 1. 3, 1.
4. K is the y coordinate of the vertex. H is the x coordinate. So if I gave you that equation, you can immediately go to 3, 4, know that that's the vertex. Furthermore, you know that A is positive, so it opens up. So when it's in vertex format, that's the best format because it gives you a starting spot instantly. You start at H and K. That is H comma K. So in this problem, that's H, that's K. Now, if they give it to you in vertex format, that's all well and good, and they could. There's 3 different formats they can give it to you in. Let's go over all of them. There's standard format. There's X-Intercept Format. And there's Vertex Format. The Vertex Format's the most common one. And I'm going to give you examples of all 3. I'll give you the same example I just gave you. That's Vertex Format. X-Intercept. I have no idea what happened. My screen just disappeared on its own. Sometimes it does that. Sometimes I can get it back. Sometimes I can't. At least not without rebooting my computer. Let's see where we're at here. Tell you what. You tell me what format it is.
Format what is?
I'm going to give you some functions. I want you to tell me the format. What kind of format is that? And your choices are standard, vertex, or X-intercept.
Vertex.
Good. Where is the vertex?
1 and 3.
Very good. How about this one? What format is that?
X-intercept.
Nope.
Oh, standard?
Standard. In other words, X-intercept format looks kind of like this. X minus 2 times X minus 3. If I had that, that's X-intercept format, and I know where my X-intercept is. And you also know that the X coordinate of the vertex is always halfway in between. So if my X-intercepts are at 2 and 3, where's my X-intercept of the vertex? Or what's the X coordinate of the vertex? Halfway
5.
between 2 and 3. You were going to do it right. I shouldn't have said anything. 5 what?
5, 1. I don't know. 5 halves.
You add the two numbers and you divide by 2. Notice where 5 halves is. 2.5. Where's halfway in between 2 and 3?
2.5, 3.5.
That's it. 2.5. In other words, you find halfway points by adding the two numbers and dividing by 2. Sometimes you don't need to do that. Sometimes you can just look. If I said, what's halfway between 2 and 4, what is it?
2 and 4, it's 3.
Yeah, you don't need to do any math to figure that out. What's halfway between 4 and 8?
4 and 8. It's wait, 4 and 8. It's 6.
Okay, now do it the easier way. Add the two numbers and divide by 2.
Add 3 and 2, or 4 and 8.
4 and 8. You get 12. Now divide by 2 and you get 6. So halfway between 4 and 8 is 6. Because you take the two numbers, you add them together, and you divide by 2.
Got it.
So what's halfway between 14 and 26?
26, 14, and 20.
Good. Add the two numbers, you get 40. Divide by 2, you get 20. 20 is 6 away from 14, and 20 is also 6 away from 26. Now,
so if we get the function, like the x minus that, instead of taking like a long route of finding the vertex, we could just take like the points from that. And
you know, depending on how they give you the function, depends on how you want to do it. And it's tough for me because I don't really know what they've taught you. I'm not sure they've taught you all 3 of these formats.
they've only taught us like one format our entire career.
Probably the Vertex format. In other words, it's probably this. But it's difficult for me to tutor you without knowing what they've taught you. And that's why it's so important for you to bring the problems to the class.
Yeah.
So that I can tell what it is they expect you to know. This is Vertex format right there. In other words, the format is of the format A times x minus h quantity squared plus some k. And your vertex is h and k.
We haven't seen that. The most familiar one I've seen in that class is the X-Intercept one.
Okay. X-Intercept one might look something like this. In other words, if they give you this one, then you know your x-intercepts are x equal 3 and x equal minus 4. Which means you're looking at a parabola whose x-intercepts are at 3 and minus 4, which means the vertex is somewhere right there at minus 1/2. If I add those two numbers together and divide by 2, I get minus 1/2. So when it's in the X-intercept format, pretty easy to figure out the X coordinate of the vertex. And this is also called the Axis of Symmetry. They've probably taught you that. And that line is x equals minus 1/2. But Josh, I really need you to bring the problems because I'm guessing here. I'm just kind of shooting blanks in the dark because I have no idea what they've taught you and what they expect you to know. So you got to help me here. You got to bring problems.
Yeah, I will next time.
Okay. The X-Intercept format, I wouldn't say that's the most common. I would actually say that's probably the third most common. The most common one you're going to get is this one here. The Vertex format, because, and that's what this is in, is Vertex format, because you immediately know where the vertex is. You don't have to do any math at all. I know the vertex is at 3, 4. And that's the most valuable point on a parabola, is the vertex. So that's always the one you want to know first, is where is the vertex. Second most important thing to know is where are the x-intercepts. So the x-intercept format is pretty nice also. Standard format, not so helpful. Standard format is ax squared plus bx plus c. The only advantage of standard format is it's not very hard to figure out the x-coordinate of the vertex because it's minus b over 2a. So that immediately gives you the x-coordinate of the vertex. Once you get the x-coordinate of the vertex, you can plug it into the function to figure out what its y-coordinate is. So there's 3 different ways they can give you these quadratics. And depending on how they give it to you, depends on how you go about finding the vertex. If they give it to you in vertex format, well, it's a piece of cake. They're giving you the vertex. If they give it to you in x-intercept format, well, that gives you the x-intercepts. Take halfway between them, you get the x-coordinate of the vertex. So that's a pretty good format to have also. And if they give it to you in standard format, you can use minus b over 2a to get the x-coordinate of the vertex.
Got it.
Kind of it in a nutshell. Let me give you some more examples. You say that the one that you think they've told you about is the x-intercept format?
After you writing it, I think it's the wrong one I was thinking of. It's the one where it's y equals x squared plus 10x, like minus or plus another number. Like I haven't, like the most common one we use doesn't have numbers in it.
That is standard.
Like doesn't have parentheses. Yeah.
That's standard format because the y is all by itself on one side and everything else is on the other. Okay. So if this is the format they're giving it to you, then there's actually 2 different ways to find the vertex if they give it to you in this format. One is you can use minus b over 2a, which works very nice to find the x-coordinate of the vertex. So let's do that. I'm not sure if that's what they've taught you either, because there's another 2 ways to do this. One is I can try to factor it. Another, I can complete the square. Have they taught you how to complete the square?
Oh, like do the square formula with it?
No. Completing the square is a total process of its own. It's definitely something you're going to have to learn before you get out of algebra. You got to use it a lot. It's just I don't want to get into it if they haven't given it to you.
Wait, well, we have done. I haven't heard like the word complete the square, but we've done this way to get functions where it's like an x, 2 numbers on the top, 1 number on top of x, 1 number on bottom. Then we have to solve for the factors of those 2 numbers.
That's factoring. That's just factoring.
Oh, got it.
In other words, I can factor this quadratic. It's x minus 5 times x plus 2. And now notice that I don't have it in standard format anymore. I've got it in x-intercept format. Where are my x-intercepts?
Your x-intercepts are -5 and -2.
No.
No, +2.
No. They're +5 and -2.
Oh, because we have to do that.
Yeah,
I completely forgot about that.
equal to 0. X-intercepts come when y is 0. So if I set y equal to 0 there, and I'm saying I got two things multiplied together equals 0, well, that means that's equal to 0 or that's equal to 0. And when I set each one equal to 0, I come up with x equal 5 and x equal -2. Well, that's pretty good because now I know that one x-intercept is there at 5, the other one's there at -2. Where's my line of symmetry at?
Your line of symmetry is at 3.
No.
Oh, wait, what? Oh, because it's a negative.
What's the halfway point between those two numbers? Add them together, divide by 2.
All right. Add them together,
-2. Arithmetic is because math is all about just doing hundreds and hundreds and hundreds of single-digit computations.
It's 1. 1 is the...
What are these two numbers added together?
-3.
No, +3.
Yeah, positive, sorry.
Divide by 2, you get 3 halves. So that is at 3 halves. 1.5 is halfway between. So I know this much. The only thing I don't know that's important is what the y-coordinate of the vertex is. How do I figure it out?
I forgot.
Here's the equation. Y equals x minus 5 times x plus 2, and I know what x is.
Don't we take the numbers and we... Oh, we do that, we plug them into the original function?
Okay. I don't have to plug them into the original function. I can plug them into the second function because it's the same thing. So all I did was factor it. So y is going to be equal to 3 halves minus 5 times 3 halves plus 2. Well, that's minus 7 halves times plus, let's see, 3.5 is another 7 halves. So that's 49/4 negative. 49/4 is the y-coordinate of the vertex. If I want to put a coordinate on that, it's 3 halves is the x-coordinate minus 49/4 is the y-coordinate. So even though I got the equation in standard format, because I could factor it, that helped me instantly solve for my x-intercepts. And when you know your x-intercepts, you know the vertex is halfway in between them. So that allows me to pretty instantly solve for my x-coordinate of the vertex. Once I have the x-coordinate of the vertex, plug it in to either that or that, they're the same equation, to get the y-coordinate.
Yeah.
And that's the process you're going to use. Over and over. Josh, you got any last questions?
No, I think I've pretty good
Try to
idea.
bring problems to the next session.
I will.
Much better. Okay. Talk to you then.
Bye.